Good evening, everybody. On behalf of Institution of Engineers, Faridabad Local Center, I welcome you all to the webinar on solar technology development for industries. We'll start the program with the lamp lighting. We'll have IEI anthem.
विश्वेश्वरैया जी के आदर्शों को मिलकर करें नमन। आओ अभियंतागण हम सब नव भारत का करें सृजन। आओ अभियंतागण हम सब नव भारत का करें सृजन। जोड़े नदियाँ सेतु बनाए, शहर गाँव का भेद मिटाए। तकनीकी शिक्षा का दीपक विश्व के हर कोने में जलाए। ऊर्जा के अक्षय स्रोतों से मनुष्य को भी करे चमन। आओ अभियंतागण हम सब भारत का करें सृजन। आओ अभियंतागण हम सब भारत का करें सृजन। अनवरत प्रशिक्षण से हम अपनी कार्य कुशलता बढ़ाएं। यातायात संचार में उन्नत प्रौद्योगिकी को अपनाएं। नैसर्गिक हो या औद्योगिक आपदाओं का करें शमन। आओ अभियंतागण हम सब नव भारत का करें सृजन। आओ अभियंतागण हम सब नव भारत का करें सृजन। विश्वेश्वरैया जी के आदर्शों को मिलकर करें नमन। आओ अभियंतागण हम सब नव भारत का करें सृजन। आओ अभियंतागण हम सब नव भारत का करें सृजन।
Now I request our chairman Sandeep Handa ji for welcoming the guests.
Thank you, Pradeep Malaji. Your effortless support to the webinars is remarkable. I, on behalf of IEI Faridabad Local Center, would like to welcome one and all on this program for solar, which is the most important energy today, and directly related to industry, to all the guests and the very able speaker, Dr. Anukar Mittal. He has been working on solar for quite some time, and I believe he'll take us through and share his knowledge today. In addition to this, to make it lively, what we have planned today is that all 20 of us, 17 present and 3 more expected to come, will ask one question each, and we look at Mr. Ankul, Ankul Mittal also, to ask one question from the audience, which he can cover it up during the presentation, so that we can make it a more interactive and more informative instead of one monologue from one side to the other participants. So this would be my suggestion, and I will try and do some 50% of our information to Engineer Ankur while the deliberations are on. Thank you, and now back to Engineer Pradeep Malaji. Thank you.
Thank you, sir. Today we have Engineer Ankur Mittal as our lead speaker. He is energy auditor, BE certified. He is pursuing MTech from IIT Delhi, and he is BE Chemical. He is also pursuing PhD from BITS Pilani. Now I would request Engineer Ankur to present his presentation. Engineer Ankur Mittal.
Sir, am I audible?
Yes, yes.
Hello. Yes. So, Honorable Chairman Sir, Engineer Sandeep Handa ji, Honorable Secretary Sir, Engineer KR Gupta ji, Moderator Engineer Pradeep Malla ji. Hello, sir.
I would request everyone to please mute their mics.
नहीं आज तो पॉसिबल नहीं हो पाएगा बताओ
मल्ला जी आप कर दीजिए सबके
अभी एक्चुअली क्या है मंगलवार को विजिट है यहाँ पर और इवन हम कल संडे को भी आ रहे हैं साइड पे अभी भी पांडे साहब भी अभी आए हुए थे यहाँ
Honorable Moderator Sir, for this webinar, Engineer Pradeep Malla ji, all the esteemed participants. Today I have got this opportunity to speak something about this solar power technology developments. So first thing that I would like to clear that I am not going to teach anything to anyone. Rather than I like to tell whatever I know about this solar power technology. The knowledge that I gained in my academics as well as my thesis work with BITS Pilani and my little experience while working in cement plants where the integration of renewable energy with the waste heat recovery is in full swing. So as we have tried that the presentation mode is having some problem. So I request you to please hear the presentation in this mode. So as now for next 1 hour, 1.5 hours, we are going to discuss about solar power, and that power is given by the god that is none other Divakara. So I like to start my presentation with a Sanskrit shlok that is Aditya Savita Surya Khagha Pusha Dhvastiman Sugan Sadasho Anu Hirna Reta Divakara. It means the sun, who is the son of Aditi, also known as Savita, is infusing life in all human beings, in the birds that takes around for all the 3 worlds. He eats up the light rays. He protects all the birds from the rains. He is he's very sparkling. That's why he is known as looking like gold. And he is the creator. He is giving the life to everyone. So this is about God's son. So now for next 1.5 hours that we are going to discuss about the solar power technology. But what is the need for discussion about this topic? So let me gather some facts for this discussion. So the facts are, if we compare 2 scenarios, one is for 2010 and next is future, that is 2050. So in this 40 years time, the growth estimated for India's commercial primary energy it will be 5.5 times. And that will require more resources for this fourth generation of energy. And of course, renewable energy, it has a very vital role in meeting this requirement. So with this increasing demand of energy, there will be related greenhouse gas emission if we depend more over the fossil fuels. So this greenhouse gas emission, it will also increase by over 50%, and that's a concern. If we talk about our self-reliancy, then 75 to 80% of India oil import, it is dependent over Arab countries. 45% of rural households in India are still not electrified. That's why there is a huge demand of energy. Right now, there's a generation of around 400 gigawatt of electrical energy by fossil fuels, and another 160 gigawatt by the renewable energy sources. So in the coming time, this demand will also increase. As we know that 70% of population in India, they live in villages, and 85% of rural households, they are still struggling for the clean cooking fuel. 70% of rural working population in India, they depend on agriculture and allied activities for livelihood. So the time has come to think about meeting the energy demand with reduced greenhouse gas emission and taking care of all these concerns. There are some more concerns that 90% of India's imported coal demand is met by 3 countries: Indonesia, Australia, South Africa. So if we talk about a liquid fuel, then again we are dependent over other countries. And similarly, for solid fuel, we are dependent over other countries because the coal that is available in India is not up to that quality mark. If we see the distribution of solar technology development, then out of all the states, 90% of major renewable sources, that is wind and solar, they are spread over 7 states. Some of our climatic condition, they are also having a reason for the development in these 7 states. But we can see that there is an enormous potential for development of solar and wind power in other states also, because as on date, India has a potential of renewable energy to the mark of 900 gigawatt. And we are trying to touch the mark of 200 gigawatts within some years. So that's the potential that we have. So when we talk about renewable energy sources, so we can see that these are the sources available that are counted under renewable energy sources. Include small hydro system if they are having a capacity less than 25 megawatt, with other forms as wind power, biopower, solar power. In the term of biopower, I like to spread information that the municipal solid waste, nowadays it is also being counted under biopower, and that I have written as urban and industrial waste power. So as there are 2 forms of solar energy, one is solar thermal and another one is solar photovoltaic. We see the time that we are going to discuss about this topic. So to discuss about solar thermal energy, it will require another session. So today we are choosing solar PV for the discussion in this webinar. Both are equally important, and in the coming slides, we will see that the applications, they have also become wider for using thermal energy as well as for using photovoltaic energy. So in the thermal energy, actually this is the passive use of solar power, where we are heating up some liquid some media by means of solar energy, and then that heat is being utilized in some applications. While in the solar PV, solar photovoltaic, we are directly converting solar energy into DC. With the help of inverters, this DC is again converted into alternative current. That AC is being used in our household applications. In the coming slide, we will also see that what are the off-grid system, what is on-grid system, and what is hybrid system, while talking about this solar photovoltaic energy. So these are some facts about the sun, that we can see that the diameter of the sun is 120 times greater than the earth. Distance is around 93 million miles. We see the core temperature of the sun, of the center, it is in the range of 10 raised to power 6 Kelvin, while its surface temperature is also to the range of 6,000 Kelvin. The main source of energy generation in the sun is hydrogen fusion. So there's a repetitive energy generation inside the sun, and all the planet they get energy from the solar. Now, why solar energy? So, first of all, the requirement of solar energy, it is generated with the threats of depleting primary energy sources. If I talk about coal, then with the current consumption level, the coal reserve, they will last up to 200 years. For petroleum products, with the current consumption, they will last for next 30 to 40 years. I'm very thankful to the measures, to the efforts taken by the government for running vehicles by means of blended fuel, by means of electricity, upcoming sources like hydrogen fuel. Some days back, there was a news that our transport minister, Shri Nitin Gadkari ji, he used it as a hydrogen vehicle for a very short distance. But yeah, this is the trailer that what we are going to see in the future. So these primary energy sources, they are going to deplete in the coming year. That's why we are forced to think about the alternative resource. And so solar, it has a very enormous potential to substitute the requirement met by primary energy sources. Thanks to the geographical area, so that especially for the developing countries, it is like a blessing that the intensity of solar energy that they get over their surface, it is very much sufficient to meet their energy requirement. Just a short while, I told that India has a potential of 900 gigawatt. So that's a huge potential. Even if we are able to extract all these potentials, so this is more than the demand that we have. The huge consumption of fossil fuel has caused visible damages to the environment in various forms. We need deforestation that is quite responsible for the climate change, and that we are also facing nowadays. We never faced such a heat in the month of April, the month of March. So it broke the record of more than 100 years. So these all are effects of exploitation of primary energy sources. Similarly, after combustion, they emit the greenhouse gases that pollute our environment. So collectively, all these reasons, they are responsible for thinking about an alternative that is solar, that is very promising. Now, this is actually about our Earth's energy budget. In budget, we consider that what is input and what is output. So for the energy, we are taking solar energy that is directly being emitted from the sun as input. So with this energy budget, you can easily see that 100% incoming energy from the sun, only 51% is being absorbed by the land and oceans. Rest 49% is reflected either to the atmosphere, either to the clouds, or from the Earth's surface. And this is not like that all these 51% energy is retained. No. Even in this 51%, most of the energy which is radiated to the space from cloud or atmosphere take share of those reflected energy, that is very substantial, 70%. So at the end, we come to know that the net energy that we get from the sun are purposeful utilization, that is 50-60%. Still, if we are able to extract all the energy available, maybe it's 15-16%, but it is quite adequate to meet our requirements. In our academics, we all have read that the solar radiation, actually there is a compilation any wavelength rays. So it's a ultraviolet rays, it's a visible rays, it's infrared rays. So out of these three available wavelength rays, the infrared rays, that is having a wavelength of between 700 nanometer to 2500 nanometer, they are utilized for this solar PV energy generation. So now I'm going to tell some interesting facts about this solar energy, that how it started, what efforts our scientists they have made in the past. So this is in 1838, Mr. Edmund Becquerel, he observed material which turned light into energy. Actually, his father was a photographer, and he used to do experiments in his father's photo shop. So one day he observed that graphite electrodes, then it is dipped into a conductive solution, and when light was coming to the graphite surface, so actually it was emitting some energy. So he came to know that there are some materials that actually emit energy. So we can say that that is a small experiment forced us to think that we have to explore those materials that actually emit energy. In 1876, there was a scientist named William Adams who wrote a book about substitute of food in tropical countries. And with his experiment, with his knowledge, he was able to manufacture a 2.5 horsepower steam engine. But at that time, cost was very high, so it didn't attract the customers. In 1860, Mr. Augustin Moscheles used direct conversion of solar radiation into mechanical power. And in 1895, Mr. Aubrey Anissa, he formed the first solar energy company. But his products were ill-fated. The first product that he sold to a person was having a cost of around $2,500 at that time. It was a very huge cost. But in a windstorm, it was destroyed. So after some time, his company bankrupted, and all the experiments they went into vain. In 1904, Mr. Henry Wilson, actually he came up with the idea that we have to store energy so that it can be utilized in non-energy generation hours, like in cloudy days, like in night hours. So he came up with the concept to store the energy. He built two plants in California to store the generative power. But up to these timelines from 1838 to 1904, the main issue was related to the cost. The cost was very high, means out of the reach of the normal customer. So it didn't go in the pace that it should be. So yeah, in 1954, there was a breakthrough innovation where from the Bell Laboratories, three scientists named Fuller, Mr. Pearson, and Mr. Chaplin, they actually worked over silicon soil and they were successful to produce a cell that was giving an efficiency of 6%. This was 1954. The first solar cell that was built in the year 1800 was having efficiency less than 1%. So you can see that it took 150 years to raise the efficiency of solar cell from 1% to 6%. That was a breakthrough innovation. So and after that, in 1956, first commercial solar cell was made. Again, the cost was very high. It was too high as $300 per watt cell. After that, some more innovation happened, and like using of solar energy in the satellites, that was a breakthrough innovation. In 1970, actually, we can see that it was a blessing in disguise. So the cost of cell, while earlier it was $300 per watt, it was reduced to $20 per watt. So with this, it started to attract the customers, and with this increased attraction, scientists, they were also motivated to work over the solar cell and increase its efficiency. Today's solar cell that we see in our time that are having efficiency of around 27 to 28%, and still experiments are going on to increase the efficiency, say 50 to 60%. So this is about working of solar panels. I will not put much time that it's theoretical, and we all know. Only I'll see that there are some materials known as semiconductor materials. So they have a property that in the two layers, that N layer and P layer, that have a energy level, and when solar energy that attacks the N cell and electron is released. So it is reached to P cell and a flow is maintained. With this maintain of flow, actually electricity is generated. And in India, mostly crystalline cells are used for this solar generation. So in this, we can see the process in pictorial view that how solar PV energy is generated. You can see that energy from sun, it's just directly coming over the solar PV cells. So with the solar PV arrays, this energy is converted into direct current. That direct current is fed to the inverter. From the inverter, it is again converted from direct current to alternative current. That alternative current with the adequate frequency, it is being used in the electric appliances that we use in our home. The thing that I want to tell here about net metering. What is net metering? And this is becoming very much popular. So in the net metering, actually, this solar setup is connected to the grid, and it has a two-way metering. Once there is a overpower generation, means the power is generated more than the demand. So the surplus power, it is fed to the grid. At the same time, when generation is less, say in the cloudy days, say in night hours, so obviously the demand is more than the generation. So at that time, the demand is met by the grid power. So at a balance, that what is fed to the grid, what is taken from the grid, the net metering is done for the units, and based on those units, it is decided that whether we will get from the grid money or either we'll have to pay the money to the grid. So this is the concept of net metering, and it is becoming very much popular. Solar PV in India, it gained the momentum in the year 1970s, where government came up with many ideas like 100% depreciation the first year of installation of system, as no excess duty for the manufacturers. It also reduced the import tariff for raw materials that were being used in the installation of solar plants. It also came up with the idea of soft loans to the users, intermediates, or manufacturers. You can see in this slide a stamp that was released by the government to increase the awareness about solar power among the public. So this is solar PV in India, that what the systems are actually available, and basically they are targeted to supply this solar energy to the rural areas. Because in the other sides, we came to know that the 45% electricity deficit in the rural area, their dependency over continuity of power due to agriculture purpose, etc. So these are the options available that are that get supply from the solar. Maybe it's water pumping, maybe it's home lighting, street lighting, whatever solar lightings. So they are summarized here. These are very interesting uses of solar energy. So solar auto rickshaw, that is nowadays it is becoming common. The second picture that we are seeing here, it is solar power vehicle Helios. This vehicle, this unmanned aero vehicles, it was developed by NASA, and it was developed in 1999. So actually, this was having a concept of fuel cell with solar cell combination. It was an integration of fuel cell and solar cell. And the target to achieve height with this Helios, it was set as 1 lakh feet. So it was successful to attain the height of maximum 96,000 feet. And in the year 2003, actually, when it was traveling to island of Hawaii, so it was crashed, and it was crashed into Pacific Sea. So, but in a short span of 4 years, it gave very much messages to the world. Yes, solar energy, it can be utilized for many more purposes other than the electricity generation. So this was a very successful operation done by the NASA. There are some more interesting uses, or rather practical application of solar energy. In the first picture, you are seeing the view of semi-autonomous war machine Odysseus. It was also developed by NASA for military operation purposes, as well as to monitor the environment. And actually, this the trial for this vehicle, it was planned in 2019, April 2019, but somehow due to some reasons, it was put on a hold for an indefinite time. Yeah, they are behind this concept, and so we can see the application of solar in such a high ambitious goals. At the bottom, you are seeing a beautiful car. Quant. It was made by a Swedish company, Koingjang, and it can attain the speed up to 170 miles per hour. It can get the 60 kilometer per hour speed in just 5 seconds. So what a beautiful car made with the uses of solar energy. The body of this car that you are seeing here, it is not just the normal body. Actually, this is solar cells. The all body of this car is solar cell. So you can see that future is ready. There are some more practical application of solar energy. Maybe it's a solar street light, solar cooker. These are very common uses that we can see in our country everywhere. In this picture, you can see that it is nowadays it is possible to run a heavy appliances like air conditioner with the help of solar energy. Even when we get the chance to visit National Institute of Solar Energy, that is on the Faridabad Gurgaon Road, there they are operating their ACs with the help of solar power. Some days back when I was searching for ACs over Amazon, also there were options to choose ACs that are uh, using energy of solar. In the right side picture, we can see a building. Again, just like that car where a body was working as a solar cell. In this, the windows that you are seeing here, they are not a normal glass. They are actually solar cells. Very thin film solar cells that are converting solar energy into DC power, and that again that DC power is converted to AC power by means of inverters. Uh, there are a wide variety of solar energy uses. And believe me, today only I'm talking about only solar PV. I have not touched the solar thermal. Similar to solar PV, solar thermal, it is also enormous uses. So that we can plan some other day. That what are the use of solar thermal energy? This is the summarization of other practical applications of solar energy, whether it's a solar lantern, it's a PV powered agriculture pump, solar street lighting, community solar cooking system. In BITS planning, the administration is also planning to set up a solar rasoi, where the solar energy it will be used to cook foods for the students. Solar food dryers and air heaters, solar inverters, PV mobile network towers. In the mobile network towers, actually, we have experienced that nowadays to increase the connectivity, to increase the network efficiency, the towers they are installed within a very short distance. So, to power up those mobile towers, they use diesel generators, but solar it can become an option to replace those diesel generator to power up these mobile network towers. In India, where we can see that logistic is a major issue. And again, quoting a recent example of COVID-19, where vaccination program, it was planned in a massive way throughout the country. So there was a problem of keeping the vaccines in at a low temperature. But not only these vaccines, but other vaccines that require to be maintained at low temperature. So photovoltaic vaccine refrigerators, they can be used. They can be utilized to keep medicines at a low temperature as per their prescribed label. They can be used for water desalination and purification. And these are the key issues related to our country, where logistic is an issue, where clean water, clean potable water is always an issue. Electricity is always an issue. So it can be used for these purposes. There will be standalone system. There will be a programming CDM approach to combine several small solar systems. So with the development of technology, we can integrate, we can combine the small solar system so that they can be used in a bigger way. In these pictures, we can see the examples of our country, where the first picture is of Tirupati Balaji, and second picture of Shirdi, Sansthan Shirdi. And here, the solar rasoi that I was talking that it is going to be installed at BITS Pilani, but here we can see that they are already being used in these places where there is a requirement of very large quantity of food for devotees. So solar energy is being used at these places. The other uses for solar PV, it is a PV powered lighthouse and offshore navigation lights that we can see in the uh, bottom picture in this slide. So there is one more advantage when we are using solar PV in this offshore application. Actually, the optimum temperature that is required for a maximum solar PV efficiency, that is around 25 degrees centigrade. So the temperature, if it is more than that, then it decreases the efficiency of solar cells. So with these offshore applications, actually nearby water serves as a cooling media, and it tries to down the temperature of solar PV cell ambience, and that is actually helping to increase the PV cell efficiency. You can see that nowadays in Delhi NCR, the shades for the vehicle shades as well as rooftop of buildings, they are covered with the PV cells, so that the area is properly utilized, as well as the requirement of electricity that is met out with such type of structures. Nowadays, PV powered directional boards, advertising banners, they are also in use. In the top picture, you can see that there's a billboard where it is a very smart line is written. That is, this is not a billboard, it is a power tool. That's a very beautiful message. PV powered insect trappers, they are also in use, using PV to charge batteries and cell phones. Actually, the applications that I'm telling right now, these show the variety of applications. Accordingly, in the industrial developments, as per the demand of that particular area, any applications can be worked out to serve the community and to run the business. For next 2-3 slides, actually, I'll touch up two sides of point. One is about the advantage of solar energy, and at the other side of point, that are disadvantages of solar energy. I'll briefly discuss here. So first, starting with the solar energy advantage, as nowadays the tariff of solar energy, it has come down from earlier 15 rupees per unit to as low as 2 rupees per unit. So with this means that's the generation cost. The generation cost, it has come down, and with the more incentive that is available by the government. So now the payback period that we can expect from a solar PV system is less than 15 years. Earlier it was more than 20 to 30 years. So that is helping to set up the solar PV plants. And the source that we are using for this energy generation, that is sun, that is actually practically free. There is no emission of gases, so the question of greenhouse gas emission, it is also mitigated. It is very clean energy. It is inexhaustible source of energy, and it does not contribute to global warming. So all these are related to the advantages of solar energy. Some more advantage, maybe there is no maintenance, there is no moving part, so there is less wear and tear. And once it is installed, so with a very minimal annual maintenance cost of say 12 lakh, 14 lakhs, they can be maintained with a good efficiency. These are drawbacks related to the solar energy. So the main drawback about solar energy is the initial cost, because the component that we are using in solar PV setup, so 85% of those components are being imported, mainly from China. So that is actually increasing the cost of this solar PV system. In the coming slides, I'll also discuss that what is the expected cost of 1 megawatt solar power plant. So there we will see that what is the component cost and other cost. The cost of solar energy is also high compared to non-renewable utility supplied electricity. Say, wind energy. Nowadays, actually, it is quite comparable. But when we compare the earlier time of solar energy with the wind energy, so there was a wide difference for the generation cost between the wind energy and solar energy. The efficiency of the system, it is a very key issue. With a feasible system, nowadays the efficiency of solar cell is 27%. That is very less. Scientists are working to increase this efficiency with a uh, feasible system, but that is in the experimental stage. Till then, we will count it under drawbacks of solar energy, the efficiency. One more drawback of solar energy I like to tell here, that the area where such type of systems are installed, so that behaves like a heat island. So in the vicinity of that area, actually local temperature is being developed. So that is very means not comfortable for the flora and fauna. It's about generation capacity of India. India, as I told you, that around 400 gigawatt of energy is generated through fossil fuels, and 40% of that energy, that is 150 or 160 gigawatt, it is generated through renewable energy sources. The IEA, that is a main nodal agency, that is International Energy Agency, it has projected that the growth of renewable energy by 2040, it will become 4,550 gigawatt. Installed renewable power generation capacity nowadays, it has increased as a fast pace over a few years, because government has set a very ambitious target, say 175 gigawatt by this year and by 450 gigawatt by the end of 2030. India, it is doing very good, but and also it is now it is leading the world, the concept of International Solar Alliance, and India, it ranks fourth in the world in terms of total installed wind power capacity, and added the second highest solar capacity in the world, definitely after China. Off-grid renewable energy capacity of India, it is also increased due to many reasons. And the solar energy production by year 2018-19, it was considerable units as 27.6 billion. There are some more facts, but as time constant and to cover up all the information, I'll skip these out. These are the strategies adopted for promoting the solar energy in our country, like full integration. Nowadays, we have companies that are producing this renewable energy in a full swing, like Suzlon Energy, Adani Power, and also Reliance. It has also come into race. So they are setting up very big power plants using for generation of this renewable energy. India is also planning to cutting it import for solar power components. So it has also set a target to produce components required for solar plants to meet out a capacity of 36 gigawatt by 2030. So by that, they are reducing their import. India is working over decentralized solar power, where the power actually that is supplied to the area, that is only of the nature of renewable energy. For that, they are developing transportation logistics system, transportation system in such a way that it has become self-reliant. The tariff, it has also come down with the investment from FDIs, and with the capable auction processes, like nowadays tariff, it has come down to 2.2 rupees 40 paisa. per unit for solar power. So all these strategies, they are helping out to making renewable energy sources more popular. There are some more policies by the government. That's a repowering policy, IURA policy, wind solar hybrid policy. Of course, there are some more plans by the government to set up solar parks. And these solar parks will add around 20,000 megawatt of solar power installed capacity. So right now, they are planning to set up 25 plants. In the future, this number will grow. Government has some more plans like National Solar Mission, wind bidding schemes, skill development, because when the system will grow, then we'll increase our capacity for this renewable energy. So there will requirement of skilled manpower. So government is working to develop Surya Mitras. So these 50,000 Surya Mitras, they'll act as a skilled manpower in solar energy sector. This will help out to increase the efficiency or maintain the efficiency of solar power systems. Government is also working for developing green energy corridor, where it is projecting for evacuation of renewable energy from generation points to the load center by creating interstate and intrastate transmission infrastructure. So all these missions, all these efforts to strengthen our infrastructure, this will help out. And also government, it has increased the budget in 2021-22 for more than 2 lakh crore that will be spent in next 5 years. So these are the government initiatives. Yes, I already told you that India has enormous potential for renewable energy, that is 900 gigawatt. And actually this is more than our requirement of energy. We can see that out of this 900 megawatt, 750 gigawatt is planned for solar energy only. So recognizing this potential, government has planned to set up 175 gigawatt solar energy potential capacity by 2022. So India is moving towards renewable sources. Right now, 40% share is of the nature of renewable energy. Government is planning to increase this share by 50% up to 2030. You can see that there's a continuous development for setting up these facilities. India is also replacing coal plants with renewable energy sources, and that is expected to save India's 54,000 crore rupees. And that is the annual cost that will be saved by India. That is due to reduced power cost. Similar or parallel to these renewable sources like wind energy and solar energy, there is also working upon compressed biogas plants. And there's a plan to set up 5,000 such compressed biogas plant by 2023. So we can say that it is a advantage India. So whether it's a robust demand, whether it's increasing investment, whether it's a policy support, or whether it's a competitive advantage. So all these are helping for advantage India and increasing the potential of renewable energy. So this is the comparison that when actually we replace 1 kilowatt home solar system, or we install a 1 kilowatt home solar system, and that will actually replace the fossil fuel electric energy. So by that, we'll able to save 170 pound of coal, because that was either it was burnt to generate electricity in a coal power plant. We are able to cut out 300 pounds of carbon dioxide for releasing into atmosphere, and 105 gallons of water from being consumed each month. So this is a gist that how solar energy, it can help to save our environment and save our results. Now, coming to the last component of this webinar, that is, there are actually two components left. One is about the cost, that what cost is required to set up 1 megawatt solar power plant, and second one related to cell efficiency. Now, starting with the components required for 1 megawatt solar power plant. So we need solar PV modules. So this is the basis is taken for 1 megawatt solar plant. So solar PV modules actually the mono PERC 400 watt cells. So this PERC refers for passivated emitter rear cell. There's a need of solar inverter with MPPT technology. This MPPT is maximum power point technology. So with this MPPT technology, there is a synchronization of the frequency or for the voltage for the inverter and for the panels. SCADA mounting system, protection device that includes surge protection devices, cables, solar structures. So these all are needed to set up a 1 megawatt power plant. Now coming to the cost, so to set up a 1 megawatt power plant, there is a requirement of near 5 crores. And in this 5 crore, actually the cost of land is not included. So the major cost is of solar panels. And I suppose that with the increasing potential of manufacturing components indigenously, this cost will also come down. But as on date, there is a requirement of around 5 crore rupees to set up 1 megawatt power plant. So this is the initial cost. Now, to run that power plant and for annual maintenance purposes, there will be requirement of around next 12 to 14 lakh rupees per annum. So now, when we talk about the payback period, because that is the most important component that is taken care by the financial people. So we can expect that with this 1 megawatt power plant, there will be generation of daily 4,000 units. So with the calculating it on an annual purpose, there will be generation of around 14 lakhs unit. Now with the cost that is set up by the government, the total income that we expect from 1 megawatt power plant is around 56 lakh. Now taking care of maintenance cost, that is again 12 to 14 lakhs. The net income in a year that we expect around 43 lakhs for this 1 megawatt power plant. Now the last point that we include in this webinar, that is solar panel efficiency, because this is the concerned area. And when this efficiency will increase, definitely the cost of solar power plant, it will come down with a attractive tariff structure. So in a nutshell, what is solar panel efficiency? This is actually measurement of solar panel's ability to convert sunlight into usable electricity. For an example, if sun is shining over a high efficiency solar panel and that rating is 20%, it means it is converting 20% of that available energy into useful purposes. So that is the meaning of solar panel efficiency. There are many technology available that are actually reflecting different solar cell efficiency. If it's a polymer cells, mono cells, other perovskite type cells. So it ranges from 18% to 22%. And that is a concern that how to increase these cell efficiency with a feasible cost. So this is the ranking of the solar panels given by different companies. And we can see that sun power, it tops in this list with a maximum efficiency of 22.8%. There are other competent competitors like LG, Panasonic, and others. They are also supplying solar cell efficiency with near about sun power solar cells efficiency. This is another one. So solar cell efficiency, as I told you, that it started in the year 1800 with a efficiency of less than 1%. And it took another 150 years to increase this efficiency to next 6%. And with the coming developments like 2012, 2015, now we stand with a feasible solar cell efficiency of 22.8%. And that is available in the market. Now, this slide is about the experiment. This is still not available in the market. They are at the experimental stage, because the material that is actually being used to increase the solar cell efficiency, it is not practical. It is very much costly. So scientists, they are working to meet out these efficiency level with cheaper material. So the time is not far when we will see that solar cell efficiency, it will reach out a level of around 47%. Even I have not written here, but in US, for 100% solar cell efficiency. These are the developments related to solar power, and that is actually the interest of industry. So that's all from my side. Thank you very much. Over to you, sir.
Please stop screen sharing.
Okay, sir.
Any questions? You would like to ask any question? I think we should have few questions.
Yeah. Well, if I'll ask the first question, you were talking about technology and all, and you spoke about semiconductors, NPN and all that. Now, as per your study, which is the better PV cell? Which formulation will be the best PV cell formulation for domestic purpose and industry?
Yes, sir. Sir, actually, for efficiency purpose, when you talk about industrial efficiency purpose, so it's a passivated emitter rear cell, PERC cell, that give efficiency around 24 to 25%. So that is the answer for industrial purpose. But when talk about our domestic purposes, so the cost, it plays a vital role.
Okay.
So in that case, polystyrene cells are mostly used. So the efficiency for these cells are 19 to 20%, but quite comparable to PERC cell.
And what would be the cost for a domestic setup of 1 kilowatt?
Sir, you're asking for per unit cost, no, sir?
Yeah. What?
So
Yeah.
it's about 4 to 5 rupees per unit.
No. I'm not asking about the cost of the generation. I'm talking about cost of the erection of one solar panel of 1 kilowatt in our domestic usage. Cost of the full setup. Any idea? No.
So I have idea for 1 megawatt. That's a 4 to 5 crores. So accordingly, we can see that what will be the cost.
It won't be like that. It won't be like that.
Yeah.
1 kilowatt.
I think Bansal sir is trying to say something.
1 kilowatt should cost around 50,000 rupees.
50,000 rupees.
Yes.
Sir, you are on mute, sir. Bansal sir, you are on mute.
The cost.
Yes, now we can hear.
Today, the cost of 1 kilowatt of solar power is coming around 35 to 40,000 per kilowatt.
Okay.
The recommended price is about 60 to 70,000 rupees per kilowatt. But if for 1 kilowatt, the size is almost very for a very minor use. And the cost goes on reducing as you go on the higher kilowatts rating. For lesser kilowatt rating, the cost is high. And then it is not only the cost, but the cost of implementation is far more higher than the cost of the installation. Because there are so many hassles around installing it. and then so many agencies involved. There will not be less than 15, 20 people involved in installing even a 1 kilowatt system.
So you mean, as per the government regulation wise, it is very cumbersome.
पांडे जी
As-
उन्होंने उठे
as-
बीच में वहीं सारा लगाया
It is as cumbersome as for even getting a connection for electricity. Here multiple agencies are involved.
Okay.
Firstly, you have to get the approval, then they have to wait 2 or 3 types of inspections have to be carried out before they approve it. And then approval is again based on many other things, how influential you are.
How influential you are.
Yeah.
Okay.
दूसरा प्रॉब्लम क्या है
सब बताओ
उसने वहां पर चप्पी लगा दी है वो चैनल जो होती है और चैनल ऐसे लगा दी मेरे प्लास्टर के सरफेस में
And then the cost of the land is very high. If in case you have now 4 storied houses,
Right.
only one roof can be used.
Right.
And out of that one roof also you may be able to use only 50% of the roof.
Okay.
Then divide it in between all the 7, 8 occupants of that building.
Okay.
It again,
Okay.
there are many hassles around. But the policy is taking place. Maybe as usual, it takes about 15, 20 years before it systemizes, if the system is in place properly.
Sir, it's already 50 years now, sir.
Yeah, it will take many more years to streamline.
Actually, the system is that now the government has eased the system. Everything they have done it online and it is time bound. Previously, it was done manually and many agencies were involved. Now they have done online and time bound.
It is time bound, but people know how to overcome that boundaries, how to bypass those time limits. People are clever in that.
I would talk to encourage it. So for
One should encourage it, one should
Yes,
go
sir.
for it. But the fact remains that it's not that easy. One has to be ready to go through the whole process.
now it's very easy. Only the issue is cost. Everyday cost is increasing. That is the main issue. And implementation is not very difficult nowadays.
The cost is coming down every day.
No, it's not. It's not. It's increasing.
Well,
Because
Sir, actually,
due
yeah,
to-
now the components they are manufactured indigenously. So
if
that is
you
the
go
factor.
if you go to the prices approved by the Government of India's Renewable Energy Ministry, the prices are coming down every year. In last 5 years, they have come down from 70,000 to 50,000. That is
your
a
point.
normal approved.
No, point very well taken. What you're saying is very right, that there were initial costs of some components which have been controlled. But what Pradeep Malaji is saying, probably the erection cost, the steel cost, the other paraphernalia is increasing.
The
So-
cost of panel itself is not stabilizing.
Okay.
It is increasing. It is increasing, not other things. Only the cost of panel is not stabilizing.
Okay. Chalo, it's nice. Anyone else would like to ask some questions?
Mr. Ankur,
Sir?
this study needs to take into account the disadvantages of the solar system, which are being mentioned in a prominent way. The storage batteries, their disposal, their requirement and efficiencies of the storage systems. These are causing a lot of problem. And environmentals are looking at a very big problems once this system takes place on
Yes,
some substantial stage.
You're quite right, sir. As I also mentioned that there's the issue of generation of a heat island for such type of system. So because local environment, it is warmed up.
Because people are foreseeing a lot of problems in say another 25, 30 years. And they say whether it will be viable at that period or not, that is again a big question. Right, thank you so much.
We have very nicely Amit ji, Ravi Shankar ji, Saigal Saab, Jaswant ji. Any interest for questions? Mr. T.S. Bisht, you are there. Any question from your side? Mr. Pramod Singh, any question? No?
You can unmute yourself.
Pramod Singh ji says no, he doesn't want to. Ravi Shankar ji, any question from your side?
Mr. Mittal,
Sir,
you had given figures for 1 megawatt generation of power and the corresponding figures for the water requirement. Your water requirement was on the monthly basis, whereas 1 megawatt generation would probably not be on the monthly basis. Maybe that you require to reconcile those figures
okay, sir.
in the units.
Okay. So monthly water, what you said could be divided by 30 and taken up? No.
It depends on how this 1 megawatt is, whether taken it over a month or whether it is taken for a short period or what sort.
1 megawatt when they say must be per day, no?
Actually,
Mr.
sir, we
Ankur-
can consider 300 solar days now.
Yeah.
Yes, sir.
Yeah.
In case you consider on the yearly basis, water requirement would also have to be considered on the yearly basis, not on monthly basis.
No, but
I'm just saying you reconcile those units. I have some doubt
sure.
on that.
No,
Sure,
one
sir.
second. No, it's a very nice question. When he says 1 megawatt, that means in a day 1 megawatt is produced. Am I right, Mr. Ankur?
Sir,
No, but the figure for water cannot be on the month basis.
No. What he said was that what he's doing is 1 megawatt per day. So in 30 days, probably what they've done is they have accumulated the water requirement for that.
That's what I'm saying. It needs to be recalibrated because 1 megawatt is never continuously produced over a month. 1 megawatt maybe 500 kilowatts on one day, maybe 1 megawatt on one day.
sir, actually,
Because-
for that, I have considered on an average basis that 400 units per day generation.
But you must be right, but I'm just saying that I have a doubt on those figures.
400.
You can check it.
400 units.
Per day.
So how many watts would it become?
That is 400 kilowatts. What he
So
means.
400
1
kilowatt.
megawatt.
Yes, 400 kilowatt.
Okay, so what you're saying is 400 kilowatts you're talking about.
So those are the figures which need to be
Sure,
checked
sir.
up.
Sure,
There
sir.
are a lot of confusion on those figures and the
Okay,
basis
sir.
of.
I'll check my source, though it was an authentic source, but I'll check again.
Nice observation, in fact, one who's taken it up, it's really good. But when you talk about any capacity, so don't you say it per day or do you say, how do you define it? When you say a system is 1 megawatt, so what does it mean? It means over a year it will give 300 megawatts.
1 megawatt means 1,000 kilowatts per second. What is a per second unit?
No.
What is a per second unit of energy? So whether it is 1,000 watts or whether 1 million watts, that is a different unit, but watt is essentially a per unit.
Agreed. Agreed. But when you decide a unit, when you say I have fixed a solar unit of 1 megawatt, what does it mean? It means when will it produce 1 megawatt? In a day?
Normally they say 5 megawatt or 3 megawatt that is generated in a whole day.
Right.
That is the unit of energy that is generated in the whole day. And what basically it should come is kilowatt per hour or megawatt per hour. Commercial unit is kilowatt per hour, kWh. That is what they call.
Right.
And that is what they charge.
That's how it's metered, sir. Kilowatt hour. Means in an hour, how many kilowatts we have consumed.
Actually, 1 kilowatt of solar panel produces 1 unit in an hour, depending on its efficiency.
Yes,
Agree.
yes.
1
So 1 kilowatt means 1 unit.
unit,
One.
1 unit, 1 in 1 hour, depending on its efficiency.
It depends how it is defined by the manufacturer.
No, nothing to be defined by the manufacturer. 1 kilowatt panel means 1 unit in 1 hour, डिपेंडिंग ऑन एफिशिएंसी। एफिशिएंसी अंकुर जी बताएंगे कितनी होती है इसकी।
So that's around
5 घंटे में
20
हमारा
23%.
थ्रू आउट द ईयर कंसिडर करें तो एक दिन में 5 यूनिट मिलेंगे आपको 1 किलोवाट से, एवरेज अगर निकालें तो
Mr.
5
Balla,
इंटू
that
5 इंटू में
Yes.
365 इतने यूनिट आपको एक साल में मिलेंगे फ्रॉम 1 किलोवाट।
chaliye.
1 into 1 not 5 into 1।
You stick to your opinion, I'll stick to
No,
mine.
no.
we are,
Question
we are
is
installing sir।
no, no.
Sir,
Pradeep ji,
let's understand this point in some different way.
Mhm.
Say we have a 100 watt of a valve, and if it is we are taking the energy for 10 hours, so that makes is the 1 kilowatt hour, 1 unit. If I increase that 100 watt to say I have a bulb for this 200 watt, so then I have to for 1 unit of this it will be running only for 5 hours. Okay, so this is the unit for the energy. Energy, which is what is the energy has been consumed. 1 unit can be consumed. Hours we don't have to confuse with the hour. That means it can be if the motor, say for example, if I have a 1 kilowatt hour motor, 1 kilowatt hour motor, so same unit can be consumed in 1 hour itself. A bulb of 100 watt, it will consume the same amount of unit in the 10 hours. So that is the concepts, I think.
no,
So
your
we don't,
principally what you said has got very logical meaning, and that is how the watt meter or the energy meter or the conversion takes place.
Yes.
What my question was, when I define that I have put a 1 megawatt solar power system, right?
Uh-huh. Mhm.
What does it mean to the user when he says 1 megawatt of system I've incorporated into my unit? So can I
Okay.
draw every hour, if the efficiency is 100%, can I draw 1 megawatt every hour? Or if the efficiency is 25%, that means 0.25 megawatt every hour.
No, this is not for the hour. This is for the whole day. That's the capacity for the day. That's the maximum capacity one can draw it. The maximum we can draw it.
So what you say is when I put 1 megawatt hour solar system, I
Uh-huh.
can draw 1 megawatt in 24 hours.
Oh, no,
Yes.
not 24 hours, sir. Not 24 hours. It's a
No sir।
sun hours, means 8 to 9 hours per day, whatever
मैं आपको सिंपल
sun
सा
is
जो
available.
हमारे इंडिया के लिए जो डिफाइन किया गया है, इट इज डिफाइंड दैट इफ यू हैव यूनिट ऑफ 1 किलोवाट, तो थ्रू आउट द ईयर यू विल गेट 1825 यूनिट्स ऑफ इलेक्ट्रिसिटी फ्रॉम
Okay.
1 kilowatt। From
Okay.
1 kilowatt you will get 1825 units in a year,
Okay. So
and from 1 megawatt you will get multiplied by 100, मतलब
1000 multiplied with 1000.
multiplied by
1000.
1000, yes,
1000.
1825 multiplied by 1000, you will get from 1 megawatt in a year.
Okay, got it. Perfect.
In a year.
So now it makes sense, very clear, that if I have a 1 kilowatt hour unit, a system in my house, I will get 1825 units in a year.
In
That's
a
all.
year, yes.
Perfect. Yeah, this is a learning, and I believe everyone should get into it. That maximum what you can draw from a 1 kilowatt hour in a year is 1825 units. If you do,
This all
Yeah.
has been considered taking into account rainy season, cloudy season, and everything.
okay, fine.
There's some rule.
Availability of sun, etc. All the things.
Okay. So that means my 1825 is not average throughout the year. 1825 is total, depending on the various factors of the sun
Not depending-
availability.
No, all factors have been considered here.
And that's what, taking all factors and taking account of sun availability.
Yes.
The probability function has been taken care, and
Yes.
that's how it has been defined. So summers, probably in the summers I might get 900, in
No.
winters
No, sir. It
Summer,
will
the
go
summer,
down
the problem is temperature.
more than
Okay.
25 degrees centigrade. So
Maximum
it's
you
go
get,
down.
maximum you get in the month of February, March, April, and then September, October, November,
Okay.
Correct, sir.
when the temperatures are moderate.
Okay. So panel temperature and the environment temperature also plays an important
Yes,
role.
yes,
sir.
yes.
So if I summarize it, I've got two learnings. I don't know about others, but I've learned two things in this. One is this: a 1 kilowatt hour solar panel system would give me 1825 units in a year, and two, February, March, April, September, October, November are the better months to have the better efficiency of a solar system.
Yes.
Those two learnings are good enough, fair enough.
Yes.
I don't know about others, but yes, this makes things little easy. So that means summers, since the environment will be the ambient temperature will be high, so the efficiency will go low, go
Yes.
down.
Yes.
Okay. In fact, I'm the only one who's talking here. There's no question from anyone. Either all the participants know everything, or they didn't get anything. Either of these two conditions, because I was trying to listen to it and I wanted to understand. So I was the most one who wanted to learn things from here. Anyway, thank you. Thank you, Ankurji. Thank you,
Thank you, sir.
Pradeepji.
There's another thing. Matlab,
Yeah,
if someone wants to install in their house,
right.
the best will be that their electricity bill will go half.
Okay.
इतना ही सिस्टम आप लगा सकते हैं जो इलेक्ट्रिसिटी बिल हाफ हो जाएगा, नॉट लेस नॉट मोर.
अच्छा.
इतना ही मतलब sufficient है considering cost, space and everything.
Okay.
Electricity bill can go to half only. That's all.
Okay. तो बट उसमें एक प्रॉब्लम आ जाएगा ना, हमारी समर्स में कंजम्पशन हाई होती है, विंटर्स में कम होती है.
नहीं, पूरे साल का कंसीडर करते हुए,
क्योंकि हम क्या करते हैं, हम मई जून जुलाई का बिल 3 मंथ्स का बिल एक तरफ और बाकी 9 मंथ्स का बिल एक तरफ होता है हमारा.
सर जब आप कम यूटिलाइज करते हैं दैट यूनिट गोज टू द ग्रिड, उसका आपको क्रेडिट मिलता है ना फिर.
अच्छा, ठीक है.
नेट मीटरिंग में तो जो एक्स्ट्रा है वो आपका एक्सपोर्ट हो जाता है.
अच्छा, नेट मीटरिंग में एक्सपोर्ट हो जाता है, तो पोटेंशियल डिफरेंस से हाई से लो में ट्रांसफर हो जाता है.
यस.
तो इसके लिए एक और मीटर लगाते हैं क्या?
यस, two meters are installed. One
Right.
is net meter,
Right.
and another meter is the this thing generation meter. Government wants to know कि आपने कितना इलेक्ट्रिसिटी जनरेट करी सोलर.
Okay.
For their data purpose, they install at your panels also 1 meter, which accounts the generation of solar power.
Okay. And when I draw that means there must be a system which manages the main grid power and the solar power. So
Yes, there is inverter which
okay.
takes care of import and export.
Okay. That means this. बोलो sir.
Your voice is cracking.
Okay. Now is it better? बताइए
Yes,
sir.
yes, it's better now.
Right, sir. So that means it's a very typical thing which takes care, if the solar power is coming, it will give the first priority to solar power and then it will take from the grid power.
Yes. Suppose you have a 1 kilowatt solar panel and the consumption of your house is 2 kilowatt. Means you are running a AC, a fridge and a fan. That is 2 kilowatt. And you have panel of 1 kilowatt. So 1 kilowatt you will get from solar. Rest 1 kilowatt you will get from grid.
Okay. Fine. Makes sense.
Yes.
Sir, how many of us in this group have got the solar system? Can you put it across or can you say, put your how many of us have got the solar panels installed in our house? Ankurji, do you have? Pradeepji, do you have?
I have.
Pradeepji has.
I do installations also.
I know that you do installations also. So that will be good. If anyone wants an installation, can always catch on to Pradeepji and get a better deal out of it, That's really nice.
Actually, इसमें क्या है, the net meter works as a battery.
Okay,
It works a battery for you. Suppose you have a battery in the solar system, so
right.
it stores energy. So instead of battery, the grid is storing energy for you.
Okay.
Extra energy is going to the grid.
So that in that case, you don't require an inverter in the house.
No, no, not, yeah. Which inverter?
The normal inverter.
No, the bad part is when you don't have electricity, then this solar system does not work.
Okay.
Because
Why
वो power कम पड़ जाएगी ना, आपका generation जो घर में requirement है, that power will fall down. मतलब 1 किलोवाट का पैनल लगा, आप बैलेंस आपको कहाँ से मिलेगी? तो ये सिस्टम बंद हो जाता है इन केस ऑफ पावर फेलियर.
तो इसका मतलब इन्वर्टर भी चाहिए होता है.
हाँ, वो आपके अपने पर्पस के लिए घर में इन्वर्टर तो चाहिए होगा.
चाहिए होगा. ठीक है. नहीं, आप कह रहे थे ना, मैं आई थॉट कि अगर इन्वर्टर लग जाता है तो इन्वर्टर की जरूरत नहीं पड़ेगी, बट इट विल बी रिक्वायर्ड.
नहीं, इन्वर्टर ये जब पावर फेलियर के केस में सोलर सिस्टम बंद हो जाता है.
ठीक है सर, ठीक है. राइट सर, we'll come back to you sir. I will know other queries.
It was a nice talk.
Yeah,
Thanks
it was.
everyone. Now I'll request our honorary secretary sir for vote of thanks.
Good afternoon and good evening also.
Good evening. Yeah, we started in good afternoon and we ended at good
Yes, yes.
evening.
Respected Chairman Sir, Engineer Sandeep Handaji, our distinguished speaker, my fellow FLC committee members and all the audience present. On behalf of the Institution of Engineers, Faridabad Local Center, I take the opportunity to propose vote of thanks to those who have directly and indirectly contributed. Our Chairman Sir, our Mother has a lot of contribution. A.K. Gupta ji also, Bansal ji, for this session on solar power technology development for industry. My sincere thanks to all the speakers, only one speaker, Mr. Ankar Mittal, for this excellent presentation and making this webinar very educative. My special thanks to the event moderator who played a very active role, Pradeep Mallaji, for organizing this event. Last but not least, I thank to our honorable IA members, all the participants who have blessed with their presence and took valuable time from their very busy schedule. Your presence and participation make this event very important to us. With these warm words and kind messages, we move to the end of this webinar. Thank you. Thank you. Jai Hind.